I don't think you mentioned 6 on the section of that thing. I just like worse.
It's
It's not an expected, so I don't think they're in spaces. Think you get better as the year goes?
I'm just happy to finish Wednesday. Instead of also have to have an hour and a half.
How's the vocab quiz? I don't think she gave us a handout for all.
What?
She didn't give us a handout for it, it's fine. Like vocab.
She said that like after we got our device.
Hi, guys. Welcome back. Yesterday you're supposed to kind of do a little bit of activity with the sine and cosine function of Desmos. I'm going to show that process through this 2.01 section here. And then we're going to quickly go to 2.02, graphing sine and cosine functions. And then tomorrow we'll look more at different types of properties, characteristics. So now we're looking at, imagine taking unit circle and putting it onto a graph. So we're looking at from a graphical perspective. We're gonna have a short quiz on Thursday, but it's gonna be a short quiz. We'll have plenty of time Friday to kind of go through exactly what you're gonna see, and we'll do a practice problems before you take the quiz. So it's just kind of like a check-in quiz. Okay, so it's not a full-blown quiz, just a check-in quiz, just to kind of make sure that we're good with what we've learned today and tomorrow, and then we'll kind of build on that next week. Okay, so if you have a unit circle or a copy of it, take it out. But I'll also have it here so that you guys can see it. But we're basically what we're going to do is we're going to take all these ordered pairs. Okay, well, we're gonna treat the degrees and the radian as our x value, and then whatever we're building, whether it's cosine or sine, or y value, we're gonna plot all those as ordered pairs and see what the graph looks like for our 6 trig functions. All right, so we have all these 6 trig functions, but we're gonna start with sine and cosine. They're kind of like the baseline. If we know sine and cosine, then everything else kind of builds on top of those two. So. But really, we're going to kind of see things from a radian perspective, even though degrees is kind of still helpful at this point. So we're going to treat this like our x value, radians as our x value, and then our sine as our y value. Okay. What we're going to do is we're going to take all those as ordered pairs and see what the graph looks like. So you guys can start filling this in. We're going to take all the special angles, and we're going to. So I have all the degrees up here. Let's just put the radian equivalent right below it. So let me just really just copy it from your unit circle as well. Right now, we're just going to be focused on the sine. So we're just going to, we know sine is corresponding to the y value. So we're really just going to take these values and put them down. So that means for 0, our y value is 0. For pi over 6, our y value is 1/2. And a couple of things to kind of help us, especially for plotting, is you know that 1/2 is 0.5. Now √2/2. Okay, we're going to see this decimal over and over again, so it's just kind of nice to just don't necessarily have to memorize it, but then I think if you see it enough, you're gonna eventually just commit, you're just gonna kind of know. And then root 3 over 2 is around 0.866. So we're gonna see those decimals over and over again. It's gonna kind of help us to just plot, find some points to plot, and so we can have a idea as to what the graph's gonna look like. Okay, so that means at 0 is 0, pi over 6 is 1/2, root 2 over 2. We're just taking all the y values and we're just putting them down. And we know that for sine, first and second quadrants are positive, right? Third and fourth quadrant are negative, so we see all these negative values start popping up. And then we're just going to translate those more difficult radicals into something that's easier to plot. So all the x values are going to be radians. So here we're starting at 0, then it's pi over 6, pi over 4, pi over 3. So the three special angles are kind of clumped together, and then the pi over 4 is in the middle. Pi over 2. So it's kind of like first quadrant, second quadrant, third quadrant, fourth quadrant. And then after this, you really don't have to put every x value down, just to understand that, it's going to start off at, closest to the x-axis, or to your 0 and pi will be your pi over 6. The middle of pi over 4, and then furthest away will be pi over 3. Okay, so we're just going to stop plotting these points. You can see these are all kind of organized already. These x values are already given to us, so we know we're going to start at 0, 0. Now all I'm doing is I'm just taking these x and y values and just trying to put it onto the graph. Okay, and I'll use the decimal version, easier to read. So at 0, we have a y value of 0. At pi over 6, we have a y value of 0.5. At pi over 4, 0.707. So think of 0.707 is between 0.5 and 1. And then 0.866 is a little bit above, somewhere between 0.7 and 1. And then at pi over 2, we're going to get 1. So that's going to hit the max. And it's going to kind of have a mirror image on this way down. 0.866, 0.707, 1/2, 0. So taking all of those y values, translating that unit circle onto a graph, this is what the sine graph looks like. You connect the dots, you can kind of imagine kind of a smooth curve building off of that. So we know about coterminal angles, right? We know that if we were to go through the cycle again, we're gonna arrive at the same y value. So we call this one cycle or one period because we're able to become, because anything after this is gonna start repeating the same pattern that we had before. So you can kind of just build the same thing from 2 pi to 4 pi as well, without having to fill in all this information, but you kind of estimate what it's going to be. So on and so forth, right? So if we keep going, it'll keep repeating. Right? So we call this from 0 to 2 pi. This is called one period or one cycle. So the length of time that it takes for the sine curve to complete its cycle is 2 pi. As you can see, if we go another 2 pi, we're going to be able to complete another cycle. So period is the distance required to complete one full cycle, and for the sine graph, it is 2 pi. Now we're going to talk about how we can take a sine graph and stretch it, compress it, move things around, and that will change. But we're talking about the parent graph, the sine of x graph, period is 2 pi. Domain is where does this graph exist? So we can extend this graph infinitely in both directions. There are not going to be any breaks. There's not any holes. There's no asymptotes. So domain is all real numbers. So the way we represent all real numbers is we go from negative infinity to positive infinity. We also use this notation, like two parallel lines and then with an R, uppercase R next to it. Range is what is the lowest and highest y value the graph goes, and what do you think the range is for this for the sine graph? Yeah, so lowest y value is -1, highest y value is 1. And we put brackets because it actually does hit those points. It actually does reach -1 and 1. The range is a set of all possible output values. Basically, if we look at all the y values, that's the output value. It's always going to stay between -1 and 1. Okay, x-intercepts, we see that the graph hits the x-axis at all the multiples of pi. Now we have some messy notation to kind of have a more formal language for this all multiples of pi, and we write it this way. We say pi k, where k is an element of an integer. So what that means is that all multiples of all multiples of pi means that it can be 2 pi, 3 pi, 4 pi, -2 pi, -3 pi. So to allow for all those values, we just kind of assign a variable and say that, hey, that variable can be any z, and z is an integer. So what that k element of integer means that k is an element of an integer. And that we're looking z is a notation for integer. So it means that as long as k is an integer and I attach k to pi, then that will give me all the possibilities of x-intercepts for this graph. because k can be -5, it could be -100, it could be -2, it could be 5, it could be 0, it could be 10, it could be 20. And that just kind of defines that, oh, k is not some decimal value. It's as long as it's an integer and we multiply that integer with pi, then that's going to be where the next intercept is for my sine graph. Okay, y-intercept, the graph is only going to cross the y-axis once, and it's only going to be at 0. Okay, maximum value. What's the highest y value that we see the graph hit? 1, right? And if we want to find a pattern for that, then we know that it's all going to be intervals of pi over 2, right? So pi over 2, 3 pi over 2, 5 pi over 2. So all these increments. So the way we name that is we say, okay, you start at pi over 2. Sorry, if I start at pi over 2, if I add another pi over 2, I'm going to hit another peak, right? So basically, because of coterminal angles, all my peaks are going to be 2 pi apart from each other, right? In a positive and negative direction. So I can say, okay, as long as I go 2 pi, could be that k again, could be some integer. It could be 2 pi, 4 pi, 6 pi, 8 pi, and that k will allow me to increment in infinite, in a negative and positive direction infinitely. And then again, we know that k, as long as we define k as an integer, we're basically listing out all the possibilities without having to do it for every individual one. We just kind of create a rule. So we can just say, hey, every instance that you can imagine for pi over 2 plus anything that's 2 pi away, or increments or multiples of 2 pi away, you're going to hit all these maximums again and again. Okay, minimum value. What's the minimum y value? -1. And we see the first instance is at 3 pi over 2, so I can just go infinitely in both directions from 3 pi over 2, just keep adding 2 pi or keep subtracting 2 pi. If I keep adding or subtracting 2 pi, I'm going to keep hitting these intervals of these points where the -1 is going to show. So again, plus 2 pi k means every 2 pi later, or every multiple of plus or minus 2 pi, because k can be negative as well. Okay, so that notation looks messy, but it just allows us to create a rule and not have to go and spend forever listing out all the possibilities. Okay, does that make sense? Yes.
When you write the integer, is it like, is it 2 seconds?
Yeah, so I think the way that I was writing it is, it's out like a 7, and then you do a 7 upside down, kind of put a line through it. Okay, let's go to the back page, and we're going to create the graph for the cosine graph. And you're going to see that the cosine graph is going to look very similar to the sine graph. It just feels like they're kind of both staggered versions of each other. So they're just kind of slightly shifted versions of each other, and we can get to the cosine graph. Okay, so let's go to page 3. Anybody have any questions on this page? Let me see if there's anything I finished. Okay, so here's something, just want to put a note here that sine starts at 0. Okay, we're always going to have to kind of create the sine graph and cosine graph. We're going to have to keep coming back to it to kind of remind us that sine starts at 0. which means that we know that cosine is going to start somewhere else. So now, same thing. We're going to treat all the radian measures as x values. And now we're going to create the cosine graph. And now we're just going to pay attention to the x values. And so it's kind of messed up here, but the x value is going to now be the y value of our graph. So all those values in pink, I'm going to treat them as the y value so that I can see, because I want to see what the cosine graph looks like. So we're not going to put anything with the y, because that's related to the sine. We're going to put down now cosine is going to start at 1, right? So 1, root 0 over 2, root 2 over 2, 1/2. Makes sense that once we get into that second and third quadrant, we're getting all these negative values, and cosine is not going to pop up to positive until fourth quadrant. Plot all these points. Start at 0, 1. look at the cosine graph, that cosine graph, you can kind of see a picture of it, even looking at the sine graph. So if I go back to my sine graph, you see how if I were to start at pi over 2 and end at pi over 2, I will have the cosine graph. So really, the cosine graph is just kind of like a delayed version of the sine graph, right? It kind of starts a little bit later, but it is kind of like a if I were to take that sine graph and just kind of shift it over, I'm going to get that cosine graph to show up. It looks a little bit different. It goes from peak to peak instead of starting at 0. And one thing to kind of help visually, kind of help students kind of see that shape is that think of cosine is a cup. Right, kind of has that cup shape, right? So, and that's kind of a nice way of remembering it, that cosine is a cup. So we know that it's going to start high and it's going to end high as well. Okay. And if I repeat that process, I can get that shape to show up again from 2 pi to 4 pi. So we know cosine and sine, they both have periods of 1. A lot of information is related, but things are a little bit staggered. So our x-intercept, our max and min value are going to be a little bit in different, slightly different locations. Okay, just like before, period cycle is 2 pi. Domain still extends infinity in both directions. Range is still what? -1 to 1, right? It just hits those peaks and valleys in slightly different spots than your sine graph, but a lot of characteristics are the same. X-intercepts, now instead of hitting at increments of pi, now it's hitting at pi over 2. So we can say x-intercept is pi over 2, but then every increment of pi, we're going to keep hitting an x-intercept, right? The cosine on its way up as well as on its way down is going to keep hitting pi. So the way I can say that, I can say plus pi k. So basically, at all the intervals of pi, as it's multiples of pi units away, I'm going to keep hitting x-intercepts. And it just indicate that, okay, k is a value that's it's an integer, right? I don't want k to be like 0.8 or 0.9. I want it to be like multiples of, I want it to be integers. So k is an element of an integer, just to specify what we're doing, what the restriction is when we're using k. Y-intercept for sine is 0, but the y-intercept for cosine is what? 1. Yeah, that's right, 1. Okay. Max value 1. Yep. And they're all occur at increments of pi, right? So I can say 0 plus 2 pi k. And that k can also extend in the negative direction because k is for all integers. So I can do minus 2 pi, minus 4 pi, minus 6 pi. Those are all covered when I create that formula. What about minimum value? -1. And we see it all will start at pi and start keep showing up every 2 pi units away. So we graphed all the in-between values, but to kind of see that unit circle can translate onto a graph. But now we're going to just pick, as we go to other sine graphs, we're just going to pick off the easiest points to graph to make it faster. Okay. So I want to kind of at least get you a feel for that sine graph, feel for that cosine graph. They're almost the same graph. There's just feels like they're staggered versions of each other. Okay. All right. So page 4. So now that we have a full picture of the sine graph, we're going to just kind of pick and choose the most important points to make it easier for us to graph. So I don't want us to have to, every time graph a sine graph, we got to plot, all these, 30 different points. So we can just narrow it down to just 5 points to make it easy to sketch. So remember the patterns and shape of graphs for sine and cosine graph. So here are the most important points. For theta, think of theta as your x value. Think of sine as your y. Theta is just a variable. We use that theta a lot for whenever we're talking about a degree or a radian measure. And for sine, here are the most important points. So we're going to start at 0. We're going to go to pi over 2. So basically all the quadrant order pairs. Okay, those are the, if we can just focus on those, everything else will just kind of fall in line. So just think about your quadrant order pairs. Yes.
Theta not a degree.
Say it again. Why is theta what?
Theta, whatever.
So think of theta as it is a degree, but we're thinking of that degree as a variable for the x-axis because we're trying to force this function onto a graph. So we're just thinking of theta as the x-axis, x value, and thinking of sine theta as the y value. So we think about sine, all your order pairs for your quadrant angles, right? So you have 0, 1, 0, -1, and then back to 0. And you guys all know this because those are the easiest order pairs that you can create from a unit circle, right? Just think of all the y value. So let's plot what that looks like. I'm just going to create 1 and -1. So I'll do 0, 0. Okay. So this is kind of like the 5 number summary here. So if you can just go 1, 1, 2, 3, 4, 5. So I'll say this is pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so sine starts at 0. It rises to its peak. It gets back to 0. It goes down to the minimum and then back to its center. We can create a pretty accurate sine graph without having to deal with all those quadrant angles because we can kind of just make the graph a curve, and that's what the graph will look like even if we were to go to all those details. So let's practice going in the negative direction as well. So I can also go negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And we can just have the graph kind of right, so we're going to get the same shape either way, whether we go negative or positive direction. Now for the cosine graph, quadrant angles. Sorry, pi and the 3 pi over 2. cosine. Look at your x value. 1, 0, -1, 0, and then back to 1. And that's a cup shape, right? So that's 0, 1, then pi over 2 to 0, -1, 0. So it starts high and ends high. Practice going the negative direction. So we're going to talk about transformations in terms of taking this parent graph and extending it and, changing the center, changing the height, changing the starting point. And the first thing is a property is called amplitude. So amplitude is the A value. Basically, it's the number that you see sitting in front of your sine and cosine graph, or sine and cosine function. So amplitude is going to tell us the distance from the center. And right now, I put that center in quotes because every graph is going to have a different center, but right now our center is 0 until we start shifting it to the max height. So then you can think of it this way, from rest to crest. That's going to be your amplitude. So if you look at the sine graph, right, now there's a peak, there's a valley, there's a peak, there's a valley. You can tell that the center is going to be 0, right? And the distance from 0 to crest, or 0 to the peak, is what? What's that distance? 1. So that's your amplitude. Amplitude is 1. You can also count from the center to the minimum. That's also 1. What about for the cosine graph? The center is at 0, right? If you look at the center of your graph, it's at 0 in terms of the y value. Okay, from the center to the max height is 1, and from the center to the minimum height is also 1. So we can say that for both these graphs, the amplitude is 1. Now, do you see a number in front of the sine and cosine? It's hidden, right? So that hidden number is a 1 right there. So it is showing us an amplitude of 1. It's just we don't see it because we don't typically put a 1 in front of as a coefficient. If it's a different coefficient, we'll put that there. But if it's a hidden one, then we know it's always a 1. Okay, so we're going to do a slight exploration into transformation. And what we're going to do is we're going to always build information from our starting point. And then whatever transformation is done, we'll make that adjustment and then we'll sketch it out. So for instance, we have y equals 1/2 sine of theta. What's my a value? 1/2, which means my amplitude is also what? So that means my graph is going to, instead of going from -1 to 1, it's going to now be what? -1/2 to 1/2. So it's just going to be a little bit kind of pushed in. So let's always start off with the parent information. So 0, and we're just basically always putting down the quadrant order quadrant values. Yes, for right now. For right now, they'll always be the same. After the quiz, we're going to explore, shifting it, but right now, these will always be the same. Think of sine. Sine always starts at 0, and it starts to rise, right? So once you know where it starts, you can kind of just build those numbers out. Or just think about order pairs along your unit circle. Now, what we're going to do is we're going to take what we have as our starting point. We're going to multiply everything through by 1/2. So if I multiply every one of these y values by 1/2, that will create the new y value that is a result of this transformation. So we're going to multiply by y value by 1/2 to create that new amplitude that I'm looking for. Because right now, this is my parent graph. So I always like to start with the parent graph and then adjust whatever I need to adjust on top of the parent graph. So what's 0 times 1/2? So 0. 1/2 times 1. Anything times 0 is 0. I can just bring all those down. 1/2 times -1. Now I'm just going to plot I'm always going to look at my x value, but my y value has been adapted. So I don't want to look at my parent anymore. I'm looking at the adapted y value. Zero, 0. Only rises up to 1/2. Back to 0. -1/2, 0. Let's practice going in the negative direction. One full cycle. Okay, any questions so far? Okay, so -4 cosine theta. Okay. What's my a value? -4, but my amplitude is just what? 4. Okay, so amplitude is going to be always a positive number. Does anybody know what this negative is going to do to the graph? Again? Good. Okay, it's a reflection. So when you see a negative in front, just know that it's doing a different thing than the number that you see. So the negative is a reflection, and the 4 is the amplitude. So it's doing two things here. It's taking the cosine graph, it's reflecting it over the x-axis, but it's also stretching the graph so that from rest to crest, it's going to be 4 units from the center to the peak. Okay, let's copy down the original parent information. Okay, cosine starts where? 1, right? Starts at the peak. Cosine is a cup, so it starts at the peak, goes down, and it goes up to the top. Here, that -4 just means that I'm going to multiply my y value by -4 to get that full transformation effect. So -4 times 1 is all the zeros, I know will just stay 0. -4 times -1 is 4. And then 1 times -4 is back -4. So you're only gonna, now that you've made your transformations, don't look at your middle column, your middle row anymore. You're just looking at the top and the bottom. The top will give you the x, and the bottom is your new y value. So 0, just start down at -4, pi over 2, pi, 3 pi over 2. So now it's on kind of like an upside down cup, because everything's been reflected. Let's go in the negative direction as well. Okay, so we've covered almost everything that we need to for the quiz, but tomorrow I still need to talk about intervals and what if we were to stretch that period or condense it. So we'll talk about that tomorrow, and then we'll be able to review, and then just graphing sine and cosine for the quiz. I'll show you exactly what the quiz will look like. Okay, and also we'll have time Friday to practice before we take the quiz.
I'm sorry, I'm just.
So for this graph, right? So normally the cosine graph looks like this. But imagine taking that cosine graph and flipping it to the other side. So this is going to be flipped here. That's going to be flipped here.
Right, that's why it continues on. Right, yeah, so that I don't. Because they're not that good.
Why is it that